So good afternoon everybody, myself Acharya Vishvendra. Today I'll discuss some of the applications of linear momentum point wise. So let's study with the first point. So the first point is momentum is equals to the product of mass and velocity. The first thing that we are going to use in the calculating questions based on the momentum, the very first thing. Second is magnitude of momentum is the product of mass and speed, as we discussed earlier. Third thing is kinetic energy is p square by 2m. Now we analyze these cases. In case A, if momentum is same, then we can say that kinetic energy is proportional to 1 by m. So we can say that larger the mass, lesser will be the kinetic energy. So this mathematical analysis, it leads to a concept that if two bodies have same magnitude of momentum, then lighter body will have larger kinetic energy or heavier body will have smaller kinetic energy. This concept has been asked many times in PYQs, that a car and a trolley are moving with the same momentum, then which is having higher kinetic energy. So obviously car has a smaller mass, so it will be having larger kinetic energy. This concept has been asked many times in PYQs of NEET and JEE Main. So that's very significant concept. Second concept here is if K is same, that P is equals to root 2 km. So we can say that for same kinetic energy, P proportional to root m. So if m1 is greater than m2, we can say that p1 will be greater than p2. So we can analyze that if two bodies have same kinetic energy, then the heavier body will be having larger momentum or the greater momentum. So this we can analyze. Third thing is k is equals to p square by 2m. So there is a relation in the changes in the values of kinetic energy and when momentum and mass gets changed. So using error formula of approximation using differentiation, we can say that percentage change in kinetic energy is 2% change in momentum minus percentage change in m. But here the assumption is that changes are less than 5% because these results are derived using calculus, and in that we approximate that errors are less than 5%. So for only that special case we can come to this conclusion. If errors are more than 5%, then we don't really need to use this formula. There will be more errors induced. So use this formula directly if errors are less than 5%. So from analyzing this, we can say that if now one thing is there, that if physical quantity is increased, take change as positive, while if it decreases, take change as negative. So we can use this analysis to solve different questions based on the momentum. Let me to revise you things again. So we are just working on the applications of linear momentum. The first thing is momentum is equals to mass into velocity. Second thing, magnitude of momentum is mass into speed. Third thing is kinetic energy is p square by 2m. Then we have special cases discussed with that, three cases. The first case is if momentum is same, that means k is proportional to 1 by m. That is if m1 is greater than m2, then k1 is less than k2. So we can say that if two bodies have same momentum, lighter body will have greater kinetic energy. This is concept behind it. Next we have is kinetic energy is same, then p is proportional to root m. So if m1 is greater than m2, then p1 will be greater than p2. That means if two bodies have same kinetic energy, then the heavier body will have larger momentum. So this we can analyze from this. Then in third case we have the formula related to the changes. So using the concept of errors, we can say that percentage change in kinetic energy is, here the coefficient 2 gets over here, 2% p minus percent m, minus because m is inversely related to the kinetic energy. So these inferences we can draw, and many questions are asked on these concepts in JEE, Main, NEET, and you can search PYQs for that. So it is these are very important concepts related to the momentum. So if you have any doubt, you can ask in the comment section. Thank you and have a nice day.